Hello everyone, welcome to the Smart Interview YouTube channel. This is Jay and Siddham. And today we are going to solve problems from LeetCode's Biweekly Contest number 136. So without wasting any time, let's get started.
So let's start with the first problem. Okay, so here it is said that we are given an integer n, which is representing the number of players in the game, and along with that we are also given a 2D called pick, and pick any element of pick is giving you two values x and y. So what it is representing is it is saying that the player x has picked a ball y. Okay? And the game also says the IF player wins the game if he has more than I balls of same color. That means let's say I have three balls, let's say red, green, and blue colors. So zeroth player should have at least one ball in any of the colors. That is, if I have one in red and zero in green and blue, I'll win the game. Right? Sorry, the zero player wins the game. And first player should have two balls of same color because for any I we need I plus one balls of same color. So that means if I have one red and one green, I'm not going to win the game. I need two balls of same color. So similarly, if I have two, I need three balls of same color. Then I can win the game. Else I will lose the game. Okay. So that is the question provided to us, and he is asking us how many players are going to win the game. Given these as inputs, how many players are going to win the game? So yeah, that is the question. Now let's look at the sample input. Let's here n is equals to 4. So when he is specifying that n is equals to 4, let's see what he is actually doing this. If we go to the constraint, these are some basic n and I values or functions. But here, if you look at it, it's saying that x of I value always is between 0 and n minus 1 included. That means if the value of n equals to 4, they are going to be pairs 0, 1, 2, and 3. Okay, 4 pairs starting with 0 coming till 3. And one more thing, the value of I of I is equals to 10. That means the different how many colors you have is 0, 1, 2, and so on up to 10. That is, we have a total of 11 colors with us. So we have to see. So if this is the case, we have to check if 0 player is the winner or not. We can just count how many balls of color 0 is the 0 player having color 1, color 2, and so on. And we should see if for every I player the count is greater than I or greater than equals to I plus 1. If that is the case, we will just we can just say that is a winner. Okay, so we can use the same logic to solve this question. So let's implement what we discussed. That is, we have to maintain a count and check how many balls does a player have of each color. So one thing we can do is, since n is equals to 4, we have 4 pairs as discussed 0, 1, 2, and 3. And the balls we just discussed can be of color 0, 1, 2, 3, and so on to 10. So we need to count for these things. So why don't we just take it as a matrix? We can take this as a simple matrix. No, first move in the pick array is 0 takes the 0 color ball. So at the respective index, we can just increment the count. Next, 1 picks 0. So first pair is going to pick ball of color 0. So increment the count. Same is doing the same again. Increment the count. Next, 2 is picking 1. Right? So 2 is picking ball of color 1. So we just write it here. Yeah. Next 2 is picking again ball of color 1. So the count is 2. Next 2 is picking ball of color 0. So we will initialize the count or set it to 1. Okay. potential is this is a matrix. By default, let's assume that all are zeros, so we can just increment the value. Right. So if we have this matrix, we can just go to each player, let's say 0th player, and check if the ith player is having I plus 1 balls at any instance or greater than I balls at any instance. Right? So yeah, 0 has 1 ball which is greater than 0. So he is going to win the game. Coming to 1, 1 also has 2 balls of color 0, so he is also going to win the game. But when it comes to 2, there are a total of 3 balls, but they are of not same type. Right? We want same type balls, and they need to be I plus 1. So yeah, this is also failing. So 3 also doesn't have any balls. So here, as you can see, our question is quite simple. If we can just build a matrix and store the values. So we use the logic and try to compare the code and check how it does. Okay. So let's continue the code part. Continue the code part. So let's start with the code part of this video. So first of all, as we discussed, we'll declare a counter for all the n players. So we have n players, so I range n, we have all the players. For each of them, as we discussed, we are going to count, frequency of each ball or various clusters. So, and we have a total of 11 of them. So this would be our counter. Right. Next, we'll just iterate through the pickering. For this pickering, we'll see the move and update the count respectively. So after that, what we can simply do is we can just in the countering select the player, that is move of 0, and select the ball colors, move of 1, and we'll increment the count. So that's it for next. Our answer is 0, the total number of players. Then for each player, we have to just check if he is winning or not. So for I in range n, for j in range 11, because we have 9 colors. I will just check if count of j is greater than I. So if count of I is greater than I, we can simply store them as everywhere, and we can bring because we already were near it. So at last when we return the value of answer. So this will be our code. Let's just run it and check. Yeah, it is accepted. Let's submit it and check. Yeah, our solution is working perfectly fine.
That is it for today's video. And if you are interested in programming and want to become a better problem solver, you can check out our 3-month long Smart Coder course, which helps you in mastering data structures and algorithms. Link is in the description. You can click on it to know more about the course. And if you like this video, please share it with your friends and subscribe to our channel for more such content. Until the next video, this is Jayan Sadam signing off.